The next three problems involve evaluating formulas. So here we have a formula. This is actually the formula for Fahrenheit, a Fahrenheit temperature given a Celsius temperature. And all we want to do here is substitute in. So we're going to substitute in C equal 25. So let's do that. So we have F is equal to 9/5. Here we have a 25 plus 32. And we're going to divide 5 into 25. So we have 9 times 5, that's 45, plus 32, and that's 77. So when the Celsius temperature is 25, the equivalent Fahrenheit temperature is 77. Okay, here's that same formula just turned around, and now we have the Celsius temperature in terms of a Fahrenheit temperature, and we want to substitute in a Fahrenheit temperature of 41 and see what the equivalent Celsius temperature is. So we're just substituting in values into a formula. So we have 5/9 times 41 minus 32, that's 9. And now we could just cancel out those 9s, and so we have the Celsius temperature is 5 degrees. That would be 5 degrees Celsius. In number 32, we have another formula. I don't know what it represents, and we just want to substitute in. So we want to figure out what n is. When a is 2, we're going to put a 2 here, and when L is 20, and when S is 110. So we're just going to substitute in some values. So let's do that. So we have 110 is equal to n over 2 times 2 plus 20. That's 110 is equal to n over 2 times 22. And let's divide this 2 into the 22. We have 11 here. So let me rewrite. So 110 is equal to 11 times n. Let's just divide by that 11. And finally, we get that n is equal to 10. Okay, here we have another formula. Actually, this is the formula for perimeter, I see. Perimeter is equal to twice length plus twice width. And here we want to find W. When P is 50, we'll put a 50 here, and L is 15. So let's do that. So here we have 50 is equal to 2 times 15 plus 2W. So we have 50 is equal to 30 plus 2W, and just subtract 30. And we have 2W is equal to 20, divide by 2, and we get that W is equal to 10. All right, now we're going to start the section on inequalities. So here we have this inequality. Let me rewrite this. We have 9 less than or equal to minus 1/3 x. And to solve for x, we're going to multiply both sides by the reciprocal of minus 1/3, and that would be minus 3. So we're multiplying both sides by minus 3. And since we're multiplying by a negative, we switch the direction of the inequality. Okay, so on the right side, we just get x by itself. And here we have minus 3 times 9, that's minus 27. So that's it, x less than or equal to minus 27. I guess it's probably better to rewrite this with x on the left, so let's do that. Okay, so that also says x less than or equal to minus 27. And let's do a graph. that represents this. So at minus 27 we put a closed dot. Oh, actually we're going to use the bracket notation. We put a square bracket because of the double line here. And we're talking about values to the left. X less than or equal to, less than is to the left. So that would be to the left. Going all the way to the left, we could say all the way to minus infinity. Now let's look at the interval notation now that represents x less than or equal to minus 27. So it sort of looks like this. It would have minus infinity, always gets a open bracket. Infinity minus infinity always gets an open bracket. And next to the minus 27, we put our closed bracket. Okay, here we have a simple inequality. Just solving for x, we're going to add 3 to both sides. And we have 2x less than 10. And then just divide by 2. And we have x less than 5. Let's represent that as an interval. So we have x less than 5. See, 5 is on the bigger side of the symbol, so 5 is going to be on the right. And on the left we'll have minus infinity. And both get open brackets. Or round brackets, because we don't have the double line here. Here we have to just simplify a little bit, so let's do that. In number 36, we're going to open parentheses, so we're going to distribute this minus, so it'll be 2 minus 3, and then minus minus is plus 2x, greater than 5. So we have minus 1 plus 2x is greater than 5. Add 1 to both sides. And we have 2x is greater than 6. And just divide by 2. And we have x greater than 3. All right, interval notation. Now 3 is on the smaller side, so that will be on the left. And we'll have positive infinity on the right with round brackets. Okay, so that's the same as x greater than 3. Okay, in 37 we have a double inequality. We want to get x by itself in the middle, so we're just going to divide that by this minus 6. And we have to do that on all 3 sides. Now because we're dividing by a negative, we have to switch the direction of both of these inequalities like that. So here we have a positive 2. Here we have x by itself. And here we have negative 5. Now notice this is backwards because we always want, in these double inequalities, we want the smaller number on the left bigger on the right. And here we have the opposite. So let's put the minus 5 here on the left and the 2 here on the right and the x in the middle. And let's make sure it reads the same way. This should say, this new double inequality should say x less than 2. Okay, so there we go. And x greater than minus 5. So there we go. Okay, and as an interval, it would look like this. Minus 5 on the left, 2 on the right. Both get round because there's no double line here. Here's another double inequality, number 38. Let's subtract 1 from all 3 sides. So we have 4x in the middle, and we have 13 on the right, and we have minus 8 on the left. And now just divide by 4. And here we have x is between 13 over 4 on the right and minus 2 on the left. 1 second, let me just erase that double line there. We have a single, not a double there. Okay. All right, so the interval notation would look like this. Minus 2 on the left, 13 over 4 on the right, and both round. In 39, isolate x in the middle. I'm going to divide by -2. And dividing by a negative, so we have to switch. So we have x in the middle. We have -10 on the right. And we have 5 on the left. Okay, so again, this is backwards because we want the bigger number on the right and the smaller on the left. So let's just switch it. Keep the x there. Let's put the 5 here and the -10 here. And let's have it read x greater than or equal to -10. And let's have it read x less than or equal to. Sorry, let me switch that around. Okay. X greater than or equal to -10 and x less than or equal to 5. Now in interval notation, we have -10 on the left, 5 on the right, and both get square brackets because of the double line here. On the number line, it would look similar to the interval. We would have -10, 5, square brackets on both, and we would shade in the interval in between. Okay, here we have, again, a double inequality. We want to isolate x in the middle, so let's start by subtracting 1. So we're left with -2x in the middle. Here we have -4 on the right, and we have -6 on the left. And now we want to divide that by that -2. And we have to switch. So here we have x. Here we have +2 on the right and +3 on the left. All right, and again, we want the bigger number on the right, smaller on the left. So let's put the 2 on the left, and let's put the 3 on the right. And let's make sure it reads the same way. It has to say x greater than 2. And it has to say x less than 3. All right, so there we go. Inequality would look like this, 2, 3. In number 41, we want to convert this graph to interval notation. So these are all the numbers to the left of 4 and equal to 4. So we can imagine that they go all the way down to -infinity. So from here, it's easy to just write down the interval. It looks similar to the graph. Square bracket at 4 and -infinity on the left. And remember that infinity and -infinity always get a round. Right, this graph looks almost like the corresponding interval, which would be -3 on the left, 2 on the right. -3 gets the round, and 2 gets the square bracket. In number 43, we want to convert this interval, 5, 8, to inequality notation. So x is between the 5 and the 8, so let's write it like that. X between 5 on the left and 8 on the right. And we have x less than 8. Okay, we don't have a double line because of the round bracket. And x greater than 5. And here we want to, again, convert to inequality notation. So let's start with 2, infinity. And again, let's picture x here. So x is to the right of 2. So x is greater than 2. All right, so, and we have a greater than or equal to symbol because of the square bracket. All right, we could also put put down a graph, okay, here we would have the 2, and numbers to the right of 2 we would shade in, going all the way to infinity. So we see that if x is here, x is to the right of 2, x is greater than or equal to 2. All right, and then we have the second one, we have minus infinity 1. All right, on a number line, we would have 1. And here minus infinity is over on the left, and we're talking about numbers to the left of 1. And because of the round bracket here, we'll put a round bracket here. All right, now for the inequality, x is to the left, all numbers to the left of 1, so that would be x less than 1. All right, let's do the last one, 2, 4. Okay, that's square for 2 and round for 4. So our graph would look like this. Square bracketed 2, rounded 4, and you just darken in the segment in between. All right, now for the inequality, we're picturing x between 2 and 4. So that's x between 2 and 4. And that would be less than 4 and greater than or equal to 2. Okay, greater than or equal to because of this square bracket. And less than because of this round bracket.